Hi, I'm Guang, I'm 15 years old. In this lesson of Techniques and Applications of Definite Integration, we'll take a look at two different examples. So you might be wondering, how are these two different examples? Well, we just have two different solids, and we're supposed to find their volumes. Alright, so we take a look at the first solid. Now, what is so special about this solid? So this solid, we take a look at what kind of surfaces is it bounded by. So firstly, you see 4x plus 2x plus z is equal to 10, and then x is equal to 0, or the y or z plane, and z is equal to 0, or the x or y plane. And then of course the surface y is equal to 3x. Right, so you might be wondering, how are we supposed to integrate this, right? But you have to be aware of which order are you integrating from first. And also you might be wondering, how do we find this volume, right? But if you have learned single integration, using single integration, you can find your area. So to find the volume, you can use double integration. It's just the integral of this double integration will be where your z reaches. Or it can also depend on what kind of solid you get. But since in this case, z is from 0 to that function, it can be our integrand, alright? So, for the first example, we have double integration. And this double integration, since from what I just said, z is from 0 to this function, where you can change this into 10 minus 4x minus 2y. And then you will choose whether you have dx dy or dy dx. Right, so this is the kind of integration we have, but of course we will still have to determine the boundary for x and y. So the boundaries for x and y, then we will have to know integrate from what to what, right? Since let's take a look at what kind of points you have on the x or y plane first. Since you have an x or y plane, and the z is basically from the x or y plane, whatever the height is. So if you can actually visualize what this is, it will pretty much be a tetrahedron. But for that, you can determine it yourself. Right, so again, what will the surface on the x or y plane look like? So on the x or y plane, let's just say we put it like this first. So we have y is equal to 3x. This is smaller, y is equal to x, whoops. So y is equal to 3x. X is equal to 0, which is your y-axis or the y or z plane. And what else? So if you're just looking at it for the x or y plane, that means your z-axis will be equal to 0. So if that is equal to 0, then you'll have 4x plus 2y is equal to 10. So y is equal to 5 minus 2x. So then you'll have 5 and minus 2x, which is a negative gradient. Right, so this is y is equal to 5 minus 2x. So that means your base area will be here. So this is your base area, and for your z-axis, then it will be extended out by how much? Right, so this is the kind of base area you will have. Now with this base area, now we can determine what the boundaries are. So if you want to integrate with respect to x, that means you'll need two different parts. So why two different parts? That is because you can have from x is equal to 0 to y is equal to 5 minus 2x, or from x is equal to 0 to y is equal to 3x. Right, so origin here, this point is definitely 0, 0, while this point up here, that will be 5. how about this point? Now this point is where you have to equate the two, which you would get 3x is equal to 5 minus 2x, well x is equal to 1, and y will be equal to 3, right? So this is what we will be seeing. Alright, so x is from 0 to, now we have to find this in terms of y. So let's just say we will take a look at the part below first. So from 0 to y is equal to 3x. Well, x is equal to y over 3. Alright. So now your y will be from 0 to 3. Next, you'll have add on integrate from 3 to 5. And this time you're going to see, so x you're going to have y minus 5, or you could just switch these two positions. So 2x is equal to 5 minus y, and then you divide that by 2. So 5 minus y divided by 2. Well, of course here it will be 0. And so this is what you will have to integrate. Right, so now that we know these boundaries, the integration part should be much simpler. So integrate from 0 to 3, 10x minus 2x squared minus 2xy. Substitute in 0 to y over 3, and then dy. While for your other part, integrate from 3 to 5, 10x minus 2x squared minus 2xy. Substitute in from 0 to 5 minus y over 2, and then dy. Alright, so next you just substitute in the values, or you have integrate from 0 to 3, 10y over 3 minus 2y squared over 9 minus 2y squared over 3 dy. And then we're going to have plus integrate from 3 to 5. So 10 multiplied in, you can have 25 minus 5y, and then minus 5 minus y squared over 2, and then minus 5y plus y squared. Right, so this is what you have left. And next, of course, we could combine a few different parts just to make your calculation in the end a bit more simpler. So starting from integral from 0 to 3, you're going to have 10y minus 3, you have to minus something over 9, which you'll have 8y squared, and then dy. Or for the part behind, this you have 25 minus 10y, and then plus y squared. Well, if you give each of them a negative half, you're going to have negative 25 over 2, so plus 5y, and then minus half y squared. So then you just have to combine these with whatever other terms you have. So minus integrate from 3 to 5, and the constant term is going to be negative 75 over 2. And for a term with y, that will be minus 5y. And for a term with y squared, that will be plus half y squared, and then dy. Alright, so this is what you will be seeing. Right? Now the next part is just to integrate each and every one of them. wait, whoops, the first term it is not a negative. This is just 25 over 2. Alright, whoops, sorry about that. Right, so this is what we will be seeing. And then for your integration, so 10 over 3y will become 5 over 3y square. And the next one will be 8 over 27y cubed. Then substituting the values of y is from 0 to 3. And for the last integration, you're going to have plus 25 over 2y and then minus 5 over 2y square plus 1 over 6y cubed. Then you substitute in the values from 3 to 5. Right, so now we're left with the last step of just substituting in the values. So for your first term, you're going to have 15 and then minus 8, then plus 125 over 2 minus 125 over 2. Then you add on 125 over 6 minus 75 over 2 plus 45 over 2 and then minus 9 over 2. Right, so then you have like 7. And from this final part, of course, if you're allowed to, you can just use a calculator or you can just try to figure out mentally. So the final part here would be 25 over 3, alright? So that is for the first example. So now that you know what kind of method you have to use, you would know how to solve your second example. But for this lesson, we will just be ending over here. So again, a summary of the methods that we have used. Now, by taking a look at the 4 different surfaces that we have, we can determine what kind of a boundary it will be much simpler to use. Whether integrate with respect to x, y, z first. And of course, this here is our base area along the XOY plane. And after we know this, then we can just get into solving what your boundaries are. And after you know the boundaries, you can determine the different integrations. Alright, so I hope for this lesson you understand it so far. I'll be ending it here, and thank you for your watching.